Hello, it's Valentine from Simplistic, and we're going to take a look at a problem out here where we have a solution of nickel chloride. A certain concentration is given to you and a certain volume, and it's mixed with another solution of ammonia with a certain concentration and a different volume. And once the solution reaches equilibrium, the question is, what is the concentration of nickel 2 plus aqueous that remains? Okay, and they've given you the Kf, or the formation constant, of nickel NH3 6 times 2 plus. So to do this problem, the first thing we need to understand is that what exactly is, like, what's the reaction we're dealing with out here. So the nickel chloride, essentially, let's put that in aqueous form. It breaks down to give you nickel 2 plus ions aqueous plus 2 Cl minus ions aqueous. Okay, and then the ammonia that we have out there that's given to us, this ammonia, it reacts with the nickel 2 plus. Okay, so the ammonia reacts with the nickel 2 plus, and that forms a nickel ammonia complex, which is NiNH3 6 times raised to 2 plus. Okay, now you don't really need to know how to that NH3 goes. You need 6 NH3s to form the nickel ammonia complex. When the formation constant is given to you in this form, sometimes if the formation constant is not given to you, you can just look it up in a table. But basically, you can back into how much NH3 you need. So out here, for example, I know that nickel 2 plus is reacting with ammonia to give me this formation constant. And clearly, based on this equation, I need 6 ammonias. So I'm just going to put a 6 out here, and that should be the complete equation. All right, so now that we know that's what we're dealing with, the next step is to understand what is given to us and what's the new concentrations. Okay, now the reason for that is because I'm just going to highlight this equilibrium. Okay, so let's think about this. So if I took Ni2 plus in aqueous form plus 6 NH3 in aqueous form, and that gives us, notice carefully, this is not an equilibrium yet, so I'm just going to put, sorry, it's not an irreversible reaction, so I'm going to put the equilibrium arrows, and that's going to give me Ni NH3 6 times raised to 2 plus, and that's in aqueous form. All right, so once I have that, I have to create my ice table. Okay, and so I need my initial concentration before I can begin. But the initial concentrations are not directly given to us. What is given to us is the initial concentration of this salt out here. Okay, and what is also given to us is the initial concentration of this ammonia. But again, we cannot use these numbers directly. The reason for that is because the volumes are mixed. You see, I have 125 ml of this salt. It's mixed with 175 ml of ammonia. So before you can, put things into your ice table, we need to do a little bit of basic calculation. Okay, so I'm just gonna do it out here in green. So for nickel 2 plus, the concentration of nickel 2 plus, let's call that M2. And we're going to use our formula, which is M1 V1 is equal to M2 V2 to solve this. Okay, so M1 V1 is the molarity, the initial molarity given to us, times the initial volume, and then M2 is the final molarity that we're trying to calculate, and then V2 is the final volume. Okay, so the initial molarity given to us is 0.0117 molar, so that's 0.0117 molar, and then the volume is 125.0 ml, and that is equal to the final molarity, which we have to calculate. So let's leave that as M2, and then V2, the final volume, is 125 ml plus 175 ml, so that is 300 ml. And then if we kind of solve this, we'll get M2 is equal to 0.004875. Okay, so that's the concentration of nickel 2 plus. Okay, So that's my initial concentration of nickel 2 plus. Okay, so let's go ahead and put that down out here. So that's 0.004875 molar. All right, so once we figure that out, the next step is let's calculate the initial concentration of ammonia. So for that, we'll use the same formula. So let's go ahead and write that out again. M1V1 is equal to M2V2. And then, excuse me, the initial concentration of ammonia given to us is 0.250. So that's 0.250. Let's call that M1. V1 is the initial volume, which is 175. So that's 175.0 ml. And then M2 is what we calculate, what's going to be the final molarity. And then the final volume is the same 300 ml because it's 125 plus 175. So that's 300.0 ml. And that gives us molarity M2 of ammonia is equal to 0.11658. And it goes on, but we don't care about all those numbers. All right, so we're going to put that out here at the bottom. I'm sorry, that's not right. This one actually ends up being 0.1458, okay, molar. I'm sorry. So we're going to put this number out here. So that's going to be 0.1458 molar. Okay. Now, what we need to understand is that this nickel and the ammonia, they react to form this. And because both of these are coming from two solutions mixing, we have to assume that, and if you just compare these two numbers, you can see that this number is clearly much less than this. Therefore, we have to assume that pretty much all the nickel given to us reacts. So we can say almost, so that little symbol means almost equal to 0.004875 is what reacts. Okay, so I'm going to put a little negative sign, negative 0. And I'm going to put almost equal to reacts. Okay, and then consequently, just looking at the stoichiometry, it should be 6 times this amount that reacts for the ammonia. So that's negative 6 times 0.004875. And then we're going to get that amount. So the same amount out there, we're going to get that as the product, the complex. So that's going to be 0.004875. Okay, and then at equilibrium, what's going to happen out here is, because this is almost this, so we're going to say that if I take this amount and I subtract this amount, now remember, this is not exactly equal, it's almost equal. Therefore, if I take this amount and subtract this amount, I don't know how much it's going to be, but let's call it x. That x is going to be the amount that's left over. And if I subtract, if I subtract this amount from this, I get, here's where I get 0.11658, and it goes on. And then, of course, on this side, I have 0.004875. All right, so now I have to put in, since Kf is given to us as 2.0 times 10 to the negative 6, let's write, I'm going to just go ahead and change colors back to blue. Let's write Kf is equal to, let's go ahead and write the expression first. So that's nickel, 6 ammonias, 2 plus, concentration of that divided by nickel 2 plus times concentration of ammonia raised to the power of 6. All right, and that is equal to, let's go and plug the values in, 0.004875 divided by nickel is x times ammonia 6 times is 0.11658 raised to the power of 6. And Kf is actually equal to 2.0 times 10 to the negative 6. So that is 2.0 times 10 to the negative 6. So now if we solve for x out here, we get x is equal to 9.7 times 10 to the negative 6 molar. And the question asks us, after mixing these samples, after the solution reaches equilibrium, what is the concentration of Na2 plus that remains, which is exactly what we are solving for, which is X. So that is equal to this concentration. Okay. I hope that made sense. Thank you for watching.